data sufficiency question, and the type of question is it's actually a yes or no type question, followed by two statements, and you need to answer. There are four options as well. So let's start with statement 1. So statement 1 says that 2x plus 5 is an integer. And based on the statement, we need to check whether this is possible to get a definite answer to the question. That means you need to get a definite yes or a definite no. If you're getting a maybe yes or maybe no, some cases you're getting a yes or some cases you're getting a no, that means this statement is not sufficient. So what we're going to do is we're going to use a picking number strategy here in this question. So we're going to pick some numbers and check what is the answer you're going to get, okay? So let's start with simple numbers. Let's say x is equal to 1 and y is equal to 1. And this condition is satisfied. So 2x plus y is 2 times 1 plus 1, which is 3, is an integer value, correct? Now, I'm just using this value, so I'm going to answer the question. Is x plus y, that is 1 plus 1, an integer value? Yes, 1 plus 1 is 2 is an integer value. You got a yes. And always keep in mind, whenever you are using picking number strategy, we should always try to prove that the statement is not sufficient. That should be your motive. Okay. That means if you get a yes in the first values you plugged in, you got a yes. That doesn't mean that it is always a yes. You should try for and more. If you don't succeed, that means this is sufficient. On all cases, you are getting a yes. But you should try. You never know. So you should always think about, okay, what values, instead of randomly picking any values for x and y and hoping that you get a no, that doesn't work here. What you need to do is you just need to think about logically which values can give you a no in this case. So to give you a no means this should not be an integer. If you're getting a decimal or a fraction, then you are getting a no for the sum of x and y, right? So that means if one of them is a fraction or a decimal, then you are getting a no. The sum is also not going to be an integer, right? So what we're going to do is we're going to think about any values for x and y. Is it possible for it to be a fraction or a decimal? That's what I'm going to check. Yes, it works. 2x plus y is an integer, right? You just need 2x to be an integer. So that means x can be a fraction as well. For example, if x is 1 by 2 and y I am keeping an integer value, let's say 1. This makes sense, right? The 2x plus y is an integer. The condition is satisfied. So when you multiply 2 times 1 by 2 plus 1, this is going to be 2 itself. This will get cancelled. You're getting 1. 1 plus 1 is 2. So you're getting an integer value. So this condition is satisfied. Now what I'm going to do is I'm going to check the question stem here. Is x plus y is an integer? So instead of x, it's nothing but 1 by 2 plus 1. Is this an integer value? You're getting a no. So now you succeeded, okay? You found a scenario where you're getting a no. So that means you got a yes as well as a no. That means the statement 1 is not sufficient. Because you got to get, in one case you got a yes, in other one you got a no. You are not getting a definite answer. Definite answer means in all cases you should get a yes, or in all cases you should get a no. Either one should be there, same in all cases. For that reason, statement 1 is not sufficient to answer the question, okay? So in statement 2, if you closely analyze it, it's of the same pattern as statement 1. X plus 2y is an integer, right? So here, you can definitely get both the answers, yes as well as a no. See, let's say if I picked x is equal to 1, y is equal to 1, this works. X plus 2y is an integer, and the answer you're going to get is x plus y is an integer. You're getting is 1 plus 1 as an integer. Yes, you're getting a yes. Then you think about it. Is it possible to get a no? Yes. If one of them is a fraction, it is possible to get a no here, right? So what works here? X should be an integer, but you have 2y, so that means y can be a fraction, which is 1 by 2. Why I am keeping 1 by 2? Because when you multiply by 2, this fraction is getting removed and you are getting an integer value, so that this condition is satisfied. So that reason I am keeping it as 1 by 2. 1 by 3 will not work. Only 1 by 2 will work here in this case. So that means the question is asking, is x plus y an integer? It's a no. Because when you're adding 1 plus 1 by 2, you're not getting an integer value. It's a fraction. So for that reason, you're getting a no. So again, for that same reason, you can eliminate that the statement 2 is not sufficient to answer the question because you're getting a yes as well as a no. So at this stage, you can eliminate option A and option B. Two options are eliminated. Now the next step is you combine both the statements. Okay, you combine both the statements and try to see whether it is sufficient to answer the question. Okay, what will you do to combine it? So what we can do here is, I know that 2x plus y is an integer value, and I know that x plus 2y is also an integer value, correct? So if I'm adding both of them, right? If you're adding both of them, that means if you're adding an integer plus an integer value, the sum also should be an integer. So you're adding them, I could say 3x plus 3y has to be an integer value. Right? If you're combining both the statements, this condition should be true. So again, I'm going to use the same strategy, picking numbers. Okay, so I can definitely start with the first x is 1 and y is 1. That work for both the cases, right? This is also true, this is also true. If x is 1 and y is 1, both of them are true. Now, what is the answer you're going to get for the question here? Is x plus y an integer? That's a question. Is 1 plus 1 is an integer? You're getting yes. You got a yes to the question step. Now, next step is, can I pick any fractions or decimals for any one of them? That's something that you should check. So when you combine this is the equation you're getting, or the condition you're getting. 3x plus 3y is an integer. So x can be a fraction like 1 by 3. Similarly, y also you can put a fraction 1 by 3. Now it makes sense. Why? Because 3 times x, this is 3 times 1 by 3 plus 3 times 1 by 3 again. This is going to be an integer because this is getting cancelled. You're getting 2 as the final result, which is an integer. So that means if I put x is 1 by 3 and y is 1 by 3, both these conditions are satisfied. You can cross check. See, first condition is 2x plus y, right? 2 times 1 by 3 plus y is nothing but 1 by 3. If you're adding it up, you are getting 2 by 3 plus 1 by 3, which is nothing but 3 upon 3, which is equal to 1. See, this condition is satisfied. Similarly, if you try the next one, right? X is 1 by 3 and y is also 1 by 3. It's 2 times 1 by 3. Same thing. You're getting 1. So both the conditions are satisfied. So it is this. You could plug in these values. X can be 1 by 3 and y can be 1 by 3. Now I'm going to cross check the question step. Is x plus y an integer? Okay, that's what I'm going to check. The value of x is 1 by 3. So I'm going to ask, is 1 by 3 plus 1 by 3, is this an integer value? The sum is 2 by 3, which is not an integer value. So that means you got a no here. So even if you combine both the statements, you got a yes as well as you got a no. So for that reason, I could say this, even if you combine it, it is not sufficient. So option C is also eliminated. So you're left with option D. That is, the question cannot be answered even by combining both the statements. So the strategy we're going to use in this question is picking numbers, okay? And always keep in mind, when you're picking numbers, your main aim is to prove that the statement is not sufficient. You should try for both cases, like yes as well as a no. So don't think that if you get a yes in the first values you plugged in, don't assume that, okay, it's always going to be the same. We should always try to get an opposite answer. Then only you will know whether it is possible or not, okay?